Okay, we're looking at number 25 here, which is giving us a function they called r of x. We're supposed to graph it and compare it to the parent function. Now, it is in vertex form, and vertex form looks like this. X minus h quantity squared plus k, where your vertex is hk, and your a values are right out in front. And really, that's all you need to graph. So for this particular function, let's see, our a value is 1/4, which means it's going to orient up, but it's going to grow slow. This is definitely a shrink. It's going to be a wider function than the parent function because it's growing at fourth the rate. And our specific vertex here, now this is tricky because we see addition. But my h value is actually a -10 because what I see in the equation is opposite because there's supposed to be subtraction. So that would have to be minus and minus. So my vertex is going to be -10, 0. Okay, so from there, I can go ahead and set up a coordinate grid in order to graph this. I need to move 10 units left, and then it's going to grow up. So I'm going to set up my axis. Plenty of room to grow to the left. So I'll make that an x-axis. And I'll set up a y-axis here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That should be plenty. This is actually going to grow pretty slow, so I definitely don't need too high of a y-axis. Let me go ahead and rewrite this function here. Okay, so with just my vertex and my a value, and let's see, I got the vertex right there. I'll rewrite the a little lower. A is 1/4. That is enough to graph. So I can go to -10, 0. And then I can just use my quadratic growth and I can go 1/4 the rate. So just a little reminder, in the parent function, right, my growth is going to be to the right 1 up 1 because 1 squared is 1. To the right 2 up 4 because 2 squared is 4. To the right 3 up 9 because 3 squared is 9. And then the same thing happens on the other side. We've got symmetry. So instead of growing at 1, 4, and 9, I'm going to do 1/4 of that. So I need to do 1/4 of 1, which means as I move to the right, I am not growing very high. I'm not going up a full unit. I'm going up 1/4 of a unit. When I go to the right 2, normally I would grow up 4 because 2 squared is 4. But I need to go 1/4 of that, which is 1. So I'm going to go up 1. And then when I go to the right 3, I would normally go up 9. I need to do 1/4 of 9, and I'll do that one in the calculator. There we go. We need to do 1/4 of 9, so times 9. That's 2 1/4. So when I go to the right 3, I'm going to go up 2 units, 1, 2, and then just a smidge more. And then just a smidge more, up 2, and then just a smidge more. And that's enough to give me a really nice shape here. Okay. Now, some people do struggle a little bit with using the a value as growth, so you can always set up a t-chart, right? I can set up an xy pair to get my growth from there. I would want to put my vertex in at the middle and then do a few points on either side. So I could do -9, -8, -11, -12, and then I could just plug those into the function. These inputs I have here in orange. So let's see, I'll do -9. I know I have that point graphed. So I would do 1/4 times a -9. Let me get that where we can see it a little better. -9 plus 10. Oops, plus 10. Quantity squared. Okay, look, and that's giving me 1/4. 0.25. That is what I anticipated what would happen as I moved 1 unit to the right. I just went up 1/4. Okay. If I do -8, that was the one where instead of going up 4, I went 1. So if I take this calculator and I input now -8, look, I output 1. I got what I anticipated I would get. So you can certainly fill out the table that way and get the coordinates the other direction. This one will be 0.25. This one will be 1. Okay, so there's my graph. It did ask to compare it to the parent function. Now the parent function I can graph on here maybe in purple. So I'll go ahead and call this R of x. And the parent function is f of x. So that would be vertex here at the origin. And then it's 1, 1, 2, 4, negative 1, 1, negative 2, 4. So clearly a little bit different of a shape, stretch and shrink. So we want to describe R of x. So we want to compare this to that guy. So a couple things have happened. One, the vertex has shifted 10 units left. So we have a shift 10 units left. We didn't go up or down. It's on the same horizontal axis. But we definitely have a shrink. So this is a shrink by a factor of 1/4, and that's because my A value was 1/4, right? And that's my growth was 1/4 the rate. Vertex is at negative 10, 0 instead of at the origin. And that describes all the differences there that we're looking for. We'll go ahead and throw the domain and the range on here just for good measure. Domain and range, this is for R of x. My domain is going to be all real numbers because that does continue in both directions forever. And my range is all real numbers but greater than or equal to 0. So that's actually the same for both the parent function and R of x. All right, I hope that's helpful. Message me anytime with questions.